Hi, welcome to my channel. In this episode of Oracle Cloud Infrastructure with Kubernetes, we will talk about how to integrate Kubernetes with Vault to enable secured access to secrets and to share the secrets with applications without modifying the applications to access Vault directly. So your architecture that we need to enable this integration in the Kubernetes servers, as you can see in this figure. We need to provide Vault. When we install the integration, we have a Vault service account. We need to create a Vault secret that we associate to the Vault service account, so we can use that secret so the Vault can authenticate in Kubernetes to see if the servers that is running can access the secret. It will authenticate and checks using Kubernetes API servers. And inside the Kubernetes, we will have a pod that we use as service integration using a secret provider class that we're gonna install. And this secret provider class will communicate through Vault and will pass the application service account, which in this case is internal app, but we can call anything. We create two service account, one internal app, one called Vault Kubernetes app. And this secret provider will communicate with Vault, and Vault will have to have a policy and a policy and a rule to associate the secret provider account with the Vault and authenticate in Vault itself. So it's a little bit complicated, but we will do step by step, and I hope you will understand. And this service provider class will create a secret. This secret will be injected in the pod, and the pod will be able to read the secret in an environment variable. This secret provider class can also use a secret store class, volume class, to create a volume. So you have two options here: inject the secret as environment variable, or inject as a volume, so we can read the secret as a file. And we will need a Vault secret cluster hull, so we can provide access to the Vault servers inside Kubernetes to read pods and to do the operations that it needs for the integration to works. And we will have a Vault TLS secret, so we can provide this certification chain for a self-signed certificate that we use to install Vault. So the communication between Kubernetes and Vault is encrypted. Inside Vault, we need to enable the Kubernetes out, configure the Kubernetes out with a GWT token. This token will be the Vault secret we create, and associate this secret with the Vault servers inside Kubernetes. Then, as I said, we need to create a policy that gives access to the secret engine we choose. And then we create a rule associating the service account, that's the service account the pod is running, to the policy we just created. And then we create the secret. So that's it for the architecture. Let's see how we integrate. Okay, I have environment in my machine here, but the things we're gonna do will serve for the Oracle Cloud infrastructure as well. They are the same steps. I did in my machine because I already did that in the Oracle Cloud, and I cannot undo. So let's have one Vault servers in a virtual machine that using a HTTPS to communicate, and I have a Minikube virtual machine with a Kubernetes cluster. So the first thing we're gonna do is to add the Hashicorp helper, and we'll add the secrets store CSI driver, which is the driver that enables the integration of the secret with another store, in this case Vault. And we're gonna do a Helm Apple update. Okay, this plugin, we're gonna install this secret store plugin using this command. In this case, I enable the synchronization of secrets, and I enable the secret rotation. So the integration is enabled. Now we will create a Vault secret so we can use the certificate. There was a problem here. The second set was not. The second set and the parameter was not read by ZSCH in this hierarchy. So I will just supergrade it, and that's okay now. Now we have the two sets, enable secret rotation and sync secret enable. Now we will install the Hashicorp Vault integration. Using these values, we will enable the external Vault with the IP address of the machine installed Vault. I will not enable the server. There is an integration when we install Hashicorp Vault with Kubernetes that we can install Vault inside Kubernetes. We're not doing that. We're using an external Vault. We are disabling the dev server as well. There is one integration called injector. The injector is a way to inject Kubernetes environments in the files in the pods. We are not enable that. We're using the CSI driver. So we enable the CSI driver, and we are adding a volume, which with a secret to the Vault TLS. And so when we communicate, we use the certificate we install in Vault, and we are mounting the certificate. And when we enable the CSI, we pass external arg talking where is the Vault CI cert. So we are just providing the certification authority certificate to the Vault CSI driver. First, we need to create the certificate. So we're gonna create a secret. So we create the secret. Now we install the Vault, the integration of Vault with the values we just created. We can check the pods with the Vault CSI provider. We can get the secrets, the listed secret. Okay, the pod is running. Now we can check that we have a service account. Which is the Vault. And this is the service account. We need to create a rule that we use to give Vault the permissions it needs to integrate. So we create a cluster rule. I'll call this cluster rule Vault secrets, and we are providing the API groups, service accounts, token, the authorization, and the resources, clusters, roles. We are providing the bind, escalate, create, update, and delete to all these API groups. Now we need to associate the rule we create with the Vault service. We're gonna associate the Vault service with the rule. Now, you can see in the architecture that Vault will authenticate with Kubernetes API servers to check and integrate with the Kubernetes. In order to do that, the easiest way is to provide static token, and by default the service account do not have one. It has no tokens, so we create a token and associate this token with the service account. For that, we create a secret. We have a secret here called Vault token. As you can see, this secret is annotated with a Kubernetes service account named Vault. Now if we check the service account, we have a token associated with it. This is the token that Vault will use to authenticate in the API server. Now we need to configure Vault. To authenticate in Kubernetes. First, I will get the secret name. So if we see that variable, it has the name of the secret we just created. This is the name of the secret associated with the service account. I will enable the Vault authentication in Kubernetes, in Vault. I will enable Kubernetes authentication in Vault. Then I will get the token that we created. This token is the secret we created. Is the GWT token. I need to get the CI cert for the Kubernetes. So when Vault Authenticate, it will use HTTPS. That's the certificate. And I need to know what is the host of the API server. Which is the IP address of the master machine. And with this information, I can configure the authentication of Vault and Kubernetes. I will write a config passing the token reviewer, the Kubernetes host, and the certificate. Now that we have Vault Kubernetes configured, we need to create a policy. I'll call Kubernetes secret. This is the policy that we will associate with the application. So we create the secret in this path and enable this policy to read the secrets. So it has the capability to read. I will write the policy, call it key8 secret. Now, this is where we enable the Kubernetes to authenticate in Vault and to associate with the policy. I'll create a rule. It bounds to a service account name, so the app needs to be in this service account. Let me check if we create the service account. It's here. And would allow anything running in the default namespace. We'll associate this service account with the secret, with the policy we just create. and we have a time lived of 24 hours. Now we create a rule. We can create the secret to access. So I will create the secrets in green. I'm going to put some value in the secret. I will put web app config, username and password. So if just check this, we have the username and password stored in Vault. Now we need to create the service account, so we integrate with the pod. We created the service account, and now is the last part, which is the test. To test the synchronization, we need to create a secret store. I will call with the provider of the secret store is Vault, and we are access the object. We're creating objects in the secret store. We call it password, and we'll call it db password. We access the key password that we created, and we create a new object called db username that we access the key username, and we pass a parameter which is the rule that we created in the vault. The rule we created here is this name. And we access the objects, passing the path for the secret. So is the secret we just created, web dev config, the username and the password. Here we created, in the previous example, we created a secret object. So it will create a secret in Kubernetes, which is the name dbpass. And then we create a pod. We pass the service account name we use it to enable the secret, enable the access. So we have to be this service account. Then we create a container and we mount a volume. We have the two options of integration. We can mount the volume using the volume, using the Vault DB secrets we created in the secret provider, which is the name Vault DB secrets. And we can mount the environment from the secret that we are synchronizing here. So we are synchronizing a secret object called dbpass. We are mounting the env from the dbpass as well. So let's check if this is working. and check the logs of the Vault CSI provided to see if is everything working. It's communicating with Vault. Let's check the pods again. So we have a pod running. Let's see if we have the secret we just created password and dbpass password and username. We have the user and dpass, just as we write here, the user and dpass in Vault. We also have a volume mounted, mount path amenity secret store. So we have db username, dpass, and db password. That's it. We integrated Vault with Kubernetes. All these files will be shared with you so you can replicate in your cluster. Thanks for watching.